Hello, my name is abucnasty, and in today's video we're going to be going over uncommon ore production and why we want to do that. So this concept is called uncommon ore, or just ore upcycling and voiding. What we do with that is we take quality modules, shove them into a mining drill, and we wind up then destroying all materials that are not uncommon. So what you're seeing here kind of in front of you is you have a constant kind of buffer of uncommon iron ore. The rest are slowly kind of showing up, but they are just going in and getting obliterated into absolutely nothing. So why are we doing this? Well, in this particular case, you just saw this for iron. This is going into the individual blades that create all of our wonderful blue science here, or chemical science. And this is used just to feed directly in so that we don't have to add quality modules, and we can just benefit from all the productivity modules that go into these machines. So this is also done for every single science that's produced for novice, so purple, red, green, etc. So if you were here last week, you saw that we redesigned our automation science. This same setup is what I promised that we would get into a more deep dive, and that's what this video is about. So we're going to be covering in this video the individual upcycling techniques, when you can actually start utilizing this technique to directly go to uncommon, because you do need a relatively high mining productivity level for this to already start working, but it is not going to be as high as you think. And I'm going to cover that here in the video. So without further ado, let's just jump right into it. So I've created an edit world for us to go through this concept together. First thing I'm going to say is this is going to need at a minimum mining productivity level 631 researched. Costs 630,000, or the last one 629,000. This goes up 1,000 every single time, so it's one of the best researches to get because you get 10% extra items every single time. That means that you're draining less materials, but it also really helps for this particular tech because it allows us to produce enough materials and not have to rely on speed beacons as much as you go higher and higher to get the quality material that you want. So what do I mean by that? So we're using quality in the big mining drill here, to that we have a higher chance to get a higher material every time we're mining into it. We mine it directly into a silo, and any other quality material is getting destroyed and voided. So common is constantly getting inserted here and getting destroyed, and the excess amounts that are inside these recyclers go into finally ones that are just touching each other, and that gets destroyed. Over here, we have a selector combinator that's reading from the silo chest, and it's saying, hey, anything that's greater than or equal to rare, it's going to wind up picking the item that has the highest number. So if you have more rare than you have epic, it'll choose the rare first. And if you have more epic, then it'll choose that respectively, all the way up to legendary. And you're seeing that that's just constantly getting inserted here. And you're seeing the occasional just cycling between those different qualities as they get destroyed. The lights here on the side are just indicating how much is currently inside the rocket silo. So we just get an idea of that. So if we completely stop it, it'll go all the way to its resting state, which is pink. That means it has a full rocket capacity of 500 items that are all copper ore. You're looking at this and you're going, hey, Abuck, don't use speed beacons with quality. It reduces the quality. And you're absolutely right. It definitely does. This is only at 16% when it's supposed to be at 24.8%. So, but as you're seeing here, once I remove those, well, this is going way slower, and yeah, we're destroying a lot less over here on the side, but that means I'm going to need a much higher level of mining productivity to get to the same speed, because this is only making 256 items per second. Whereas when I add these speed beacons back, well, this is now making 1,670. So that's enough for us to actually do this. And if I delete this here, you're going to see this is 1,256, and we're starting to get these little gaps forming in here, so it's not quite high enough for us to do it. So we do really need that second one in here for this to work. I'll go over a little bit more into distribution effect and why that works out with the math if you're interested, so stay until the end of the video and I'll go do a deep dive on that. But if you're here just to see like, hey, how do I get into it? This is your setup. I'll have a blueprint book in the middle of the video so you can kind of go and see a tutorial on that, so skip ahead if you just want to see that. But if you're interested in all the different stages and what I'd recommend when you can transition from this blueprint to the other ones that I'll have in this blueprint book, stick around and we'll go through that here in a second. So we're here now at the second stage, which I'm calling, I kind of care about waste. What do I mean by waste? Well, let's go ahead and jump up to the next number. So that is going to be 1174. So again, one off up. So this you're going to notice here, I just have this noted so that we can kind of have an understanding. This is going to destroy 972 items per second and keep 240, which is going to be the uncommon version. And that works because we now need a speed beacon with just a speed 1 module in it. So we don't need speed 3 or speed 2 anymore. So this is nice because we're still creating enough per second, but actually the ratio works out where we actually don't, even though the other one was producing substantially more, right? This is producing now 3,084. In the other setup, it was closer to 1,400, I think it was. Let's just confirm that real quick. We'll go back here and look at the number. So it's 1,670, I was wrong. So you need to produce more materials, and that actually makes sense here because if you're looking at the numbers, the 1,670 minus 240, we're going to have about 1,427 that's getting destroyed all the time for everything else. So then compared to the new one, once we get to the higher mining productivity levels, so 1175, well, now we only need to destroy 972 items. So that's a huge drop. That's already a drop of almost 500, right? So us going to a higher mining productivity levels means we just naturally boosted it to now making 1,200 items per second, but we're now getting 240, and that's because the quality's gone up. We're now at 22% quality. So getting to this mining research level, now you're getting into the millions, but if you're producing, let's say, 1 million signs per minute, which is pretty much on any hardware, is pretty easy to do for space age if you make the proper UPS optimizations. So that means that it's taking about a minute to research each of these levels. So 300 minutes or will get you, 300 levels, etc. So really, in terms of levels away, this is still, it's a cost and it's going to take a while to run, but this is kind of like, hey, I can leave this running overnight and I can get to that level. So this isn't too bad. So this means that your miners can still have to run at the same amount. So you're not saving any UPS technically here, but you are draining substantially less resources in the process. So this is a really good setup to get to if you want to say, hey, I just want to run this for hours and hours on end. This is the setup that I want to get to and don't feel so bad about destroying the materials. So good spot to be in. I've shown here just another example of how this is kind of tileable and where you can set these up. One thing I wanted to touch on is these take up a lot more space on patches, right, than having these just all next to each other, because this is taking effectively almost 4 mining drills width here in terms of the space. So I'm going to touch here on this end cap. There's another way that you could configure this. So let's delete this here and showcase that. Stack inserters in practice can take 120 items per second when they're going direct insertion. So with that being said here, we could have a setup that is just facing each other like this. And this will work just fine as well. The only reason that I've opted for having this alternative setup where they're facing out in a way and not pointing towards each other, and the excess that builds up in here, because this is destroying 75% materials and always only getting 25% back, was just mainly for the smaller footprint. This might be more UPS optimized than this setup here because this is not using these stack inserters. This has more stack inserters, right? So this has 12 versus this one only having 8. So it's not as ideal to maybe for UPS, but for the setup that I'm going to show in the very end at the extremely high levels, you're not even using rocket silos anymore. So I've kind of made it a moot point. I don't care as much about this being as slightly less UPS efficient. I care more about space because I had a harder time fitting these onto novice patches. So that's the compromise I made to make this setup here the final version compared to having something like this. So we're going to go to the next stage. So this is stage 3, which I'm calling the efficient megabase. This means you're finally at the point where you don't need speed anymore. Yay! But all right, it costs a lot. So to get to 2,658, we're basically just jumped up in speed. So let's go 1 up. So this is the optimal ratio. So this means you have maxed it out. You go any higher in mining productivity from here on out, you're just going to slow down how long these are working for. So that's good for UPS because they're not running as often, but basically this is at this point, the main benefit that you're gaining here is you're not destroying quite as many materials and you're getting a lot more uncommon So you've already reduced substantially the amount of materials you're avoiding. So just looking at the original setup, that was like 1400 something here. Yeah, 1427. We dropped that by 600 per second that we're reducing. So that's a substantial amount, right? So this is kind of your fission mega base. Same thing here as we showed before. So now if you're like, cool, I'm good with just letting my PC run for a multiple days on end. All right, well, for a little bit more, you can finally get to what I'm calling the UPS only zone. So this is not using rocket silos anymore. So we're gonna jump up to the mining productivity that it needs, which is 5,325. In practice, I found that this is actually 5,340. So let's go up to that. I'm not quite sure why. The math that I did shows that this should work, but it just sometimes I still have a slight issue with these inserters pulling things off, and so having it at about 5,340 for a little bit extra makes this solid, so this is running constantly. Once it gets kicked up and is working completely fine. So the way that this works is we're now pulling in and out of a cargo wagon. The reason this is better for UPS, even though we have about the same amount of stack inserters, slightly less, so that's good. But the main reason that this is the case is that we're not using rocket silos anymore. When ships are hovering over a planet, there's an interaction between the rocket silos, even if they can't launch, and the overall ship that's there, because it's telling you how it has to constantly calculate and check, can I launch from it? And there's some mechanics there. So it's better in general not to use a rocket silo at all. And it doesn't really matter for other planets like Vulcanus and Fulgora. Ships are only going to go over there when they need to grab some science or drop off like some materials for you to build something, so it's not that big of a deal. On Novice, it becomes more of an issue because you're going to have all kinds of ships hovering over there. At least you're going to have it for space science, dropping calcite down, and all the other sciences from at least 4 other planets, right? So at minimum, you're going to have 5 ships just for science, and then any other delivery ships that come over. So that starts to add up pretty quickly. And I'm not even including Prometheum, so it's probably another 6, 7. You can have 8 easily just hovering over Novice, right? So those interactions all start to add up, and it's better to use things that don't interact with anything other than themselves. So that's where these cargo wagons come in. This is the best design I could come up with. The reason that I haven't shown it in other videos yet is because I had some issues with it. So with the setup here on the right, this is what I was using. This still works and makes 240 items per second. You can totally use it. It just has the very rare potential to seize up. And it's really only on startup. And it just happens to be that in the same tick, you happen to have enough of the rare or above items to actually cause this to stick. And then you might have rare in one side and epic in the other. And then the whole system basically just shuts down. So it just means that once you place it, you have to monitor it, and you might have to go and basically replace a miner, or not the miner, but the recyclers. So but I don't recommend this setup, but you can definitely use it. Just have to keep an eye that it might jam the very first instance. Once it's running constantly and it has a little bit of a buffer of some materials in it, it's fine. It'll just keep running. So, and I've tested that because I've run it for 10, 12 hours plus, just running mining productivity, and it's not an issue in the base. And they're still using this older design. The newer design is better because it has a single place where it is constantly just destroying higher quality items. And the way that I made this work so this doesn't jam up because you're constantly shoving different types of materials is I just read that the working signal here. So if W across both of these is 0, that means these aren't working, and then the inserters check and say, cool, it's 0, I can shove something in there. So they'll do that, and they'll pull from both sides here and constantly be pulling items and throwing them in there. So that's how this one works. It's the most compact and most UPS optimal one that I could create. So this is just, again, very high mining productivity level. If you're doing uncommon altogether, tungsten is its own beast, and it actually requires to be a much higher mining productivity level. So let's just get into that right away. So pretty much you're not going to get away with anything other than rocket siloing here for this, because in order to start upcycling to create uncommon tungsten ore, you're going to need, again, that's that same setup that we had in stage 1 with the number of beacons. However, the problem here is that the time it takes, or if you look at, tungsten ore, for example, it has a mining time of 500%. So it takes 5 times longer for you to mine something out of this. So if this is running originally at a base speed of 2.5 per second on regular ore, this is now going to be only 0.5 seconds, or one item, basically every 0.5 seconds. So 0.5 items every second, sorry, not 2.5 per second. So for that reason, you just need a much higher mining productivity to even really get into this. So this is at a minimum 3,190 that you're going to need to get to in order for it to work. The same thing scales as you go higher and higher. There is just a scaled factor because of the slower speed here. So I've created a different combination that actually happened to work here with that. So that's 4,032. And then the numbers just start going wild. So stage 3, we're wasting slightly less, but now we're at basically my mega base level, so 7,619 in order for this setup to work. And that's all great, but this is still just, you're getting into the millions of mining prods. So for me, on my base, for example, this would take almost 2 minutes for me to research this, which isn't that big of a deal, again, in the grand scheme of things, but it means I'm only going up 30 levels every hour. So it takes a lot longer now to start going up these levels. So to go up 100 levels, it takes me 3 hours to get there, right? So that's just something to be aware of. This just costs a lot more to get to this level here. But then if you want to start going into just absolutely ludicrous mode here, this is what I'm calling PC running many nights. If you want to get to the fully efficient version, this is now at 13,325. So just in perspective, this is going to cost 13 million. That means for each level, my base that runs at 4 million ESPM, or science that it can consume, or not consume, but the research rate that it's running at, that's going to take over 2.5 minutes, or just over 2 minutes. So 2 minutes 25 seconds for it to, or 15 seconds for it to actually research this. So now we're really slowing down how fast this actually is going to happen. So I'd have to really bump up the amount of mining prod that I actually am producing on Novice to make this happen. Finally, if you want to use the UPS optimized version, you can pretty much forget it. This is at the stage of PC running even more nights, and that's the stage 5. And then if you want to get to the point where you're not using any beacons at all, this is what I'm calling stage 99. Your PC is going to be running until Factorio 2.1 is released, because to get to research prod 26659, or 658, it costs 26 million science per research level. So, right, that is just an insane figure. So you're going to continuously be running. I don't think this is practically a realistic number that you're going to hit for any mega base of any scale. I'm going to include in the blueprint book just because, but just know that that's the number if you want to truly have the optimal ratio and not need any more beacons. So just something to keep in mind. Again, I'm going to post in a second all the different combinations of beacons and everything that I calculated to figure all this stuff out. But the next thing that I want to go into is how do you use the blueprints in the blueprint book, and how do you get them to fit over a patch? So we'll talk about that next. So we're going to pretend we're on Novice, and I have set here, just for example, let's say my research productivity level is, not research, but mining productivity level is, I don't know, let's say it's 900 or something like that. So I've researched up to this and I go, cool, I want to start transitioning to uncommon science. So then I would go and grab this blueprint book that I've created. This will all be on Factorio bin, so you can just copy the specific book at the particular mining prod that you're at. So the one for tungsten and then the one for mining prod. So since I'm at 900, I'm not quite here yet, so I can't start going to these versions. Let me go ahead and just pick this mining productivity book. And I've made this so that it's scrollable, so you can pick any of the different flavors. So if you want just the 240 version and pack those in as good as you can use that. If you want to go ahead and just use the 480 that I've created, you can throw that in. And it's also expandable over time. So if you just need the 240, you can put this in here. Cool. Select the iron ore, and that is the filter for it. You could then go to the 480, slap that in here as well, switch to that version. And then finally you can go to the 960 and shove that on there as well. And that's just kind of conveniently already routed for you. And then you can basically drag them wherever you need to afterwards. So that is at least the setup, but you can just see just how much space this occupies. If you run a slightly higher resource size, that will help you out a lot. Some people consider it cheating. I don't, but if you want to do a fully stock default settings run, this is a little bit harder at that point. You'll probably need to grab from multiple patches. But that being said, I'm just going to show it on a couple other places. So let's say I want it to grab some of this coal here. Then I just select here, select the coal recipe. Again, it just immediately starts out putting everything onto here. And then finally, if I want, copper, which we've already demonstrated before, but I will just run it here as well so we can see it all activating and running. So that would be what you would look like on Novice. If we transition to some random place, I'm just going to pretend this is Vulcanus for a second, and I have a pretty large resource patch like this. I would switch, and I'd need at least 3,190, so now I got to wait a long time. Let's say we're at like 3,500 now. Whoopee, I've gotten there. And I go and I say, all right, cool, I want the same setup. Well, that's when you can finally start using these and start slapping them down and start using that. So that is as simple as these blueprint books are. That'll be in the video description below if you are interested in using them. And that's it in terms of this overview on using rocket silos and upcycling / voiding them. I'm going to go through some math here now in a second on how I calculate this and why I don't think that any other level is actually practically useful in the next part of this video. So stick around if you're interested in that, if you just want the blueprint books, and that's it. It's in the video description, and enjoy it. For those that are more the data nerds like myself, let's get into that portion next. So how did I come up with the numbers that you saw in the video? Well, first off, why did I do it? Well, I was thinking about it when I was recording this. I was saying, well, I could go and share just the final designs that I came up with and then say, well, there's some other speed modules that you could put in there, but, go and try some different combinations. You'll probably find something that's better. And just giving a blanket statement that you need to be at my mining productivity research level, which is at 8,000. That's not fair. I don't think that's a fair ask to tell people, hey, you need to get to 8,000 in order to make this work. Because I know that's not the reality, as we've already talked about in this video. So I went forth and I said, all right, I want to know all possible combinations of speed modules. So speed module 1, 2, 3, etc., and efficiency modules, along with combinations of beacons of either 1, 2, or 3 beacons. So I chose that specifically because as you add more beacons, the transmission strength of the beacons diminishes by the inverse square root. So it winds up being so that, like, okay, if I have 3 beacons here and I only have a speed module 3 in here, then the ratio is completely different than if I just had just 1 beacon. So I wanted to figure all that out. I tried it out in Excel, and then I said, all right, look, I personally know how to write code, so I'm gonna go and write a simulator for this. So just if you're more interested in like the actual code stuff, stick around until the very end of the video. I'll briefly go over that. But this is all going to be available on my GitHub repo, so if you want to do a deep dive into how I wrote the simulator to calculate all the different combinations, you can look into that. I made it generic so that I can use it for future videos, so that's the main reason I invested some time into that. And use it for calculating sulfur upcycling techniques and what's more optimal as we get into chemical science soon. So that being said, what this simulator does, it says give me up to 3 beacons because that's what I can fit in my particular design, and cap it so that the amount of voided material doesn't exceed 1440 items per second. And that's because there are 1, 2, 3, 4, 5, 8, 12 total inserters that are pulling items out of the silo chest, and those are limited to up to 120 per second each. So that's 1440 items per second that it can totally take out of there. So I've limited it to that. There's a lot more combinations that could work if you don't set that artificial limit. And but I didn't want to overly bloat the final CSV files of this output. So that's what this looks like. And I made one more concession. I briefly talked about it that in here, this beacon configuration is the exact same as this beacon configuration in terms of the speed increase. So all the combinations you're seeing in the CSV, it prefers the higher tier speed module, over this combination. And then other than that, it just chooses a random combination, because you're going to find a lot of combinations that would still work at this particular speed and efficiency module combo. So I've just made that concession to just limit the results so you're not seeing a whole bunch of different additional mining prod levels that would work. So what I mean by that, so this CSV file and the way that you would use it is you could basically say, all right, if I want to use the configuration that was shown with upcycling and directly inserting into a silo, you would pick that, all right, that's the number of miners that I'm using is 2. So then you could start and say, all right, I'm at 631, which we said was the minimum. And then that shows that speed 3, efficiency 3 combo that is being put in there with 2 beacons. So if you stuck around to this portion of the video, you're going to find out that there's actually a lot more combinations that work compared to just the 4 that I showed in this video. So the big pro tip here is I chose those for very specific reasons, because they're kind of at the min and max levels of those different setups and some decent transition points, but there's way more that you can choose from. So if you, for example, say, cool, I have the blueprint book, and which I'd highly recommend you just go grab that from the video description below, and then say, all right, I'm going to take that combination. So let's say I have this and I'm at, let's say 750 is my mining productivity level. So I pick the 631 blueprint book and I'd say, okay, here's my speed module combos. I'm going to slap this down and put it on an ore that's there. Then I'd say, all right, I'm at 700, so I'm not quite here yet. I can either wait a little bit more and get to 704. And let's say I research that, cool. Or I can just say, I'm just going to use a 681. I'm going to call it a day. I've already researched a little bit more. Then I can swap out and just go down to 1 beacon, remove the other extra 2 that are there, and just put speed 2s in both of those. Then what that's already done compared to the 631 is you've already gained the ability that instead of voiding 1427 per second, well, now in this setup, we're down to 1329. And that same logic applies as you go on. And just to make this kind of easier to understand, like, this is pipe delimited and just says, all right, for each beacon that you have up to 3, if it's blank, that means do not place a beacon. And if it has something, that means it needs at least that number of beacons. So for example, the most complicated case here, I'm at level 760, let's say, so I choose this one. This would be then a combination of speed 2 and efficiency 3, speed 3, efficiency 3, and then just efficiency. You could technically just put nothing in this extra beacon, but I needed something to show that it exists, and you might as well use efficiency and lower your pollution value. There's a cap. You probably only need just these 2, and this one can be blank, and you can swap the quality modules into any of the different beacons and it's totally fine. So this one could be speed 2, speed 3, and then the rest could just be efficiency and you'd be fine. So that's kind of the nice thing, is you can just pick any of these, put them into the speed modules, and it will work completely for your setup. So that means that you have a lot more combinations where you can slowly transition as you continue to go up, and you can cap it out and say, I'm done. I don't want to research more. Cool. So you just pick that one and call it, and that's enough. The nice thing is just it's going to start slowly reducing the rate that you are voiding things. And I'm off by 1. That's for the 1 miner case. So if you have 2, then you're just saying, cool, I'm slowly transitioning until I get to the point where I'm at my absolute optimal level, which is when I get to 2658 for that setup, and I'm just using efficiency modules. You could literally just delete all the beacons and you're fine too, but pollution, keep that in mind. So what that means then at this point, you're voiding the least amount of total materials. So why do I think that rare is not a viable thing? And I stated that before I got into this portion. So I don't think it's viable with just voiding. There's an argument that could be made that you could potentially have a lot of recyclers with quality modules in them. And you could take the extra amount that you're voiding, so the 820 items that you have here, and just put them directly into quality recyclers. You're only going to get 25% of those items back, and then even less for the actual Q2, and then substantially less as you're seeing here, so the same ratio applies. So you're probably only going to get up to maybe 30 if you're just straight destroying all these items. So we can still calculate that and try that out maybe one day. I'm not as interested in it because I don't think it's a viable strategy with just voiding. You would need a much more complicated quality upcycling method. So I'm talking like you're going to be quality upcycling chests and all the other shenanigans you're going to have to do to make this more viable. So or blue circuit upcycling, or anything with productivity that makes sense. So not a viable strategy really if you're just voiding. So for voiding, uncommon still makes sense as a pattern, just rare. And then as you can see here with like Q5, getting to the point of like having legendary, you're only getting 0.27 per second. And you're voiding so much more just to get to that point. So voiding is not the way to go if you want higher quality items. So, but if you are interested in uncommon, definitely a viable strategy. Use this lookup sheet. I've created 2. I've also have in the link, this will also just be rendered when you look at the GitHub page. You can just click on the Q2 for tungsten and you can have that same lookup chart. It's nicely rendered on GitHub, so you don't need any fancy editor to look at that stuff. So this chart here just basically shows that sheer drop off that we were just showing as we were going through the 2 miner setup. And then you can also have a couple different combinations that work for the 1 miner setup. I will just say if you're using the 1 miner setup, just know that the rate that you can void things is less because there's less inserters on that. So I would pick a higher number and then your mileage may vary and try different ones out. So I'd probably start at like 17 or something before really getting into that. So just something to look out for. But that is the rate there. And then tungsten, like we talked about before, it has the exact same pattern here. It's just scaled up 5 times. So you need a lot more of these. You just need a much higher productivity level to get to that. These lists are exhaustive. They have every single possible combination and the minimum required, so you can use them. And you can wait until 2.1 is released if you want to get to the final tungsten ore, all efficiency, ultra UPS optimized version. I personally am not going to research until that. So, but if someone does, I would love to see a video or some screenshot that shows that, and I will give you the most kudos points in the world for it. So for the people that have stuck around this far into the video, hats off to you. That was a lot of data I just threw at you and a whole bunch of numbers. So use those CSV files. They're going to be a good reference point. I'm going to be using them in my own Megabase as a point if I do eventually a Let's Play series. So stick around and subscribe if you're interested in that. Otherwise, for those that are still interested in continuing on and seeing some of the code, I'm going to talk about that next. I'm going to be using this code for this particular series to calculate more things. So this is written in TypeScript. I chose it just as a language because I'm already familiar with it. I don't primarily code in this every day, but this is a language that is easy to quickly set up. So this is not a simulator, and I didn't set this out just to create a simulator just for mining productivity. This can actually work for any kind of quality upcycling, and I plan to use this for future videos, like when we get into chemical science, for example, and trying to figure out sulfur upcycling techniques there. So I'm going to be using it for a lot more. That's why I invested the time to actually calculate and create this module. So if anyone's interested in working on this, or I would happily accept a pull request on any edits that you want to do. So the way that this works is I've gone ahead and tried to model this as close to the game engine as possible. So speed modules, for example, this uses the actual ratios of how much they increase at each level. I found this in a forum because I needed the exact values because the UI actually lies to you and it gives you a rounded value of how much the speed is increased. So instead of it being the actual value that's under the hood, which I actually needed for this calculation because I was getting rounding errors and needed to eliminate them. So I've done the work of trying to also model these as being an effect, and that's how the game engine works too. So just to make this really simple, I just said, all right, there's a speed multiplier, a quality multiplier, a productivity and efficiency value. I didn't wind up implementing efficiency modules because I don't care about power, but so they're just stubbed and mocked out so that I can use them as placeholders, but they're there just so that I can have the full thing. And then there's one item that I created. So I create a composite of all of them just to make it easy for me to just say I have all of those all the time. And when it does that, I needed to round them because it turned out, and I had to find this in a forum post, and thank you to the developer that actually posted about it. But before the effect is finally applied to an actual item, it is rounded to an integer at that point. So I had to round all those values, and then finally the numbers all worked out to be exactly what I see in the game. So that was a nice discovery when I figured this one out. So just wanted to touch on that. The way the mining productivity calculator works is pretty easy then. I can just very simply just define all the different speed modules that I want from that registry again, just pull them all out. So, and I needed to calculate the power set of all combinations. So for the programmers that are out there that know that, that's basically just all combinations of this one with this one, this one with this one, this one with this one, etc. And I needed a combination of up to 2 different items because you can fit 2 modules in a beacon. So that was what I created here. And then finally, I put some placeholders for an extra case where you have both efficiency modules. And that was effectively how I set all this up. And then I did some filtering on it because I knew that, all right, there's going to be a lot of combinations where your speed multiplier and the number of beacons are going to be the same. Like we talked about for L1, L2 is going to be the same as L3 by itself with an efficiency module. So when they all happen to have the same beacon effect, so that's how I group them, and when it had the same effective speed and quality, then I would say, all right, well, for those, I'm just going to filter it down, and I'm going to say just pick the one that has the highest tier module in it, and just pick that one every single time. So, or the one that has the most of that tier, like the highest tier value. Otherwise, it just goes through and just simulates until the quality 2 of the production rate. So that's just over here, just when the production rate, and this calculates all those values based on how the game decides to calculate the base, the productivity level, and then the new rate. And then I calculated then based on the quality ratios for uncommon, rare, epic, and legendary. This is generic enough so I can use this for anything. So it's can be any kind of building producing something that has a speed beacon impacted by it. So I'm definitely going to be using it in the future for other calculations that I want to do. So that just goes until the max voided rate, until it exceeds the target. And as long as it also doesn't exceed the max voided rate per second, then it'll just shove it out, throw it into the CSV file that I had, and it writes it to it. So that's kind of an overview of what this code does. And I have a whole bunch of extra things that I've added for the future. So that is an overview on the code. So for this channel, I don't plan on going a lot into code. I just wanted to kind of overview it for those that are interested. And then also selfishly, I'd love some help if people want to write more stuff in here or are interested in it. So happily accept a pull request. But so don't expect me to go in this channel a lot into code unless there's a huge desire for it. But this channel is going to be focused primarily on Factorio, and that's all it's going to ever be. So if you stuck around to this portion of the video and you've gotten this far, thank you for listening to me ramble for a bunch on the code that I wrote. I love coding. It's a thing that I do as a passion. I also love Factorio, and those things also can really collide a lot. So wonderful thing. So anyway, so outro stuff. My name is abucnasty. Thank you so much for getting this far into the video. I'm looking forward to continuing on with this series and seeing you in the next video. So subscribe and follow for more. Peace.